In this video, we will look at how to use the truth table generator that we're going to be working with for most of the course. So the link for that is right here on the class. So click on that. Here is the generator. So the first thing you'll need to do is set it up for working with SL. So first you need to set it for the right truth values. So it's already the default setting is T and F. Those are the truth values that we use. Um, Another possibility is T and upside down T. The upside down T is an alternative symbol for false. One and zero, actually, we talked about in the previous video as alternative interpretations of true and false. The next thing that you want is to set the right set of connectives. So this last set down here, these are the connectives of SL, right? Horseshoe, triple bar, ampersand. Um, Note though, these are the display connectives, right? This is what will show up in the tables that it prints. These are not what you use to input the tables. What you use to input for them is listed down here, right? So for disjunction, you use keyboard V. That is just like the dat or the hyphen followed by what is that angle bracket, right? Two angle brackets with a hyphen in between them for the biconditional, and then you can ignore these bottom three down here. We'll talk about NAND and NOR in a little while, actually, a couple of videos from now, and absurdity, I think we'll talk about when we're doing derivations. Um, there's some examples of what the inputs can look like. Um, one thing to note, if you look at these, there are no square brackets. You can only use round parentheses in your inputs. One thing that I have found when working with this is that if you've got complex sentences, um, because of the difficulty of keeping track of which parentheses go with which, it's it's sometimes easier if it's a very complex sentence to actually write it out with square brackets in it, just to make it easier to keep track of the pairs. And then once you've got the sentence entered, go through and delete the square brackets and replace them with parentheses. Um, that might help. Anyway, so we will now hear the sentences that we're gonna put in. So we'll start with this one. Z implies X or Z. Um, Now we can't remember that we can't use the horseshoe or that. So the way that we will enter this is as follows. Z, and then we'll do the arrow, X, V, Z, and then generate table. And there it gives us the truth table. And there are several options here for table type. So here you have full table. If you go to main connective only, it only gives you the values under the main connective. And note, if we go back to full table, that instead of marking the main connective with an arrow, what this does is it gives you the values in red. So that's how it tells you which one the main connective is. It will also, if you select it, it'll give you a version that's formatted in text. And you can also, if you want a fancy looking LaTeX table, you could do it like that. But we'll go back to the full table for now. Um, okay, if you look at this table that is just generated, the values under the main connective here are all true, right? It's all T's. And what that tells you is for all possible combinations of inputs to this, all possible combinations of truth values, right? Or all possible combinations of values of the atomic components, all the different ways that you want to think about it. This sentence always comes out to be true. So this is a logical truth, right? Or more specifically, what it is truth functionally true. And we define truth functionally true as being true on every truth value assignment. This is the SL version of logical truth. I mean, remember that when we're talking about logical truth, Right. What I was saying was that the notion of logical truth is like it's kind of vague, and we have more specific versions of this that we define for each system that you're working with. Truth functional truth is the precise version of logical truth as we define it for SL, right? To define it precisely, what we do is we define it for truth value assignments. And so something is truth functionally, or a sentence is truth functionally true if and only if it is true on every truth value assignment. And you can see what this table establishes is that this sentence is truth functionally true. Okay, next sentence we'll look at is this one, right? It's not the case that A implies A. So to enter this, go tilde A hyphen angle bracket a parenthesis generate table. And it gives us a nice little table for that. Here, again, the main connective here is the negation, right? And here, what you see is that the column under the main connective here is all Fs. Um, that tells you that this, right, on every truth value assignment is going to be false, right? There's only one atomic component here, which is A, and on both possible values that A can take, this sentence turns out to be false. So this is truth functionally false. It is false on every truth value assignment, right? This is the SL version of something that is logically false. Last sentence we'll look at is the longer one down here, right? A if and only if B implies not A or not B. I'll type this out. We'll have to do, so the triple bar we need to replace with this ASCII version of the double-headed arrow. And then we go not A, V, not B. Generate table. Okay, now here we have 3 trues and a false in that column. The proportion does not actually matter. The thing that matters here is that it is sometimes true and sometimes false. This is neither truth functionally true nor truth functionally false. So the term for that is truth functionally indeterminate. On some truth value assignments, it is true, and on some truth value assignments, it is false. So to review what we have learned, we learned the definitions of truth functional truth, falsity, and indeterminacy. So a sentence is truth functionally true if and only if it's true on every truth value assignment. And the way that you test for this is you look at the column under the main connective for that sentence, and it's going to be truth functionally true if that column is all T's. Sentence is truth functionally false if it's false on all truth value assignments. You test for this if the column under the main connective is all F's. And a sentence is truth functionally indeterminate if it's true on some truth value assignments and false on others. And you test for that by looking to see if the column under the main connective is a mix of T's and F's.